All right, so the unit circle and the sine and cosine. We're not going to mess around with tangent really as we go forward. Really just sine and cosine. Because as you go out in the real world and you look at things, sine and cosine are the most commonly useful things, but we have to take it out of the right triangle to deal with some angles greater than 90. I think a quick review would be in order from geometry. Call this note number 1. I got 2 of them. So let's go to our notes page. Okay. And this will be note number 1. Trigonometric or trig functions or ratios, I should say. I'll just call it trigonometric review, trig review. How about that? Okay. You guys all had geometry. If you have a right triangle, let me draw a right triangle down here. Help us out a little bit. And we'll call this A, B, C, all with capital letters. And then with lowercase, I'll identify the sides. A, this will be little side B, lowercase c. Okay, so the sine of an angle, some angle theta. Does anybody remember what that is? Remember opposite, adjacent, hypotenuse stuff? Remember SOHCAHTOA? Anyone remember that? Can you all hear me? Am I?
Yes, I don't know.
Okay. I don't know if you can hear me or not. Sine is the side opposite the angle divided by the hypotenuse. Right?
I think I know what you're talking about.
And okay, what about cosine of one of our angles? What would that be?
The cosine would be the
Adjacent
adjacent to the
over hypotenuse, right?
yeah, hypotenuse.
Okay. So in this right triangle over here, if I was taking a look at angle A, a reference angle A, the sine of angle A would be what in this case?
Would be the obtuse, the C.
Opposite. No. Well, what's the
Opposite
side?
adjacent.
What's the side opposite of angle A? What's it labeled as?
B.
No, opposite. Side opposite of angle A.
Oh,
So that would be A over, what's the hypotenuse labeled?
A over
What's the hypotenuse?
the hypotenuse would be CB.
Well, I got a C in there, right?
Yeah, C.
Okay. What about the cosine of angle A? What would that be? What over what? From the diagram.
Would be C over
No. Adjacent.
adjacent B.
Which would be what? What's adjacent to angle A? In other words, the side next to it, but not the hypotenuse.
B.
B over
B
hypotenuse.
over the hypotenuse, which is C.
C. Okay. Let's switch over to angle B, the other acute angle. What is the sine of angle B in that diagram? What over what?
B over A.
No, hypotenuse.
No, B over C, sorry.
C, yep. And the cosine of angle B is what over what?
C,
What side is adjacent to angle B next to it?
A.
A, right.
A over C.
C also is, but it's not the adjacent. We call the hypotenuse, right? So it's A over C, right? Okay, remember that stuff? SOHCAHTOA. We're not going to deal with the TOA part today, right? But up until now, right? So the sine and cosine of these two acute angles, right? It only works for angles less than 90. Works for angles less than 90 degrees, right? Because those angles that we are looking at are the acute angles. They can't be 90, right? Because then the triangle would add up to more than 180, right? So we only have one right angle. The other two have to be less than 90. So it only works for those until now. Okay? Let me take that right triangle and put it in the coordinate plane. And we're going to call it the unit circle. Remember what unit rate is, right? Okay, unit circle, where the center of this circle is at 0, 0, and the radius of our circle is just 1. Okay, so let me sketch this out real quick. So in the coordinate plane, this is hard to draw super accurately, but give it our best shot. Let's draw a unit circle. Close enough. Here's our center, okay? And I said the radius is 1, didn't I? So let me draw a radius in there. That's r equals 1. Now let me do this. What have I just drawn inside this unit circle? What kind of triangle? Well, I just put a right angle in it, so what kind of triangle is it?
It's a right triangle.
Okay. And do you see this angle here, that like the ones we've been dealing with? We're going to call this angle here theta. Where it
Yeah, so theta, and the other one would be.
It starts on the x-axis, right? And opens up to some number of degrees, right? Now, if I was to take the sine of angle theta in this triangle, right? Wouldn't it be this opposite side over the hypotenuse? But what's the hypotenuse?
The hypotenuse is r. Wait, no.
What measure did I give it?
1.
1. If I divide anything by 1, does it change anything?
No.
So that radius of our circle is now the hypotenuse of our right triangle. And sine and cosine both get divided by what? What do they both get divided by?
They both get divided by the hypotenuse. I mean,
the hypotenuse. And in this case, the hypotenuse is 1, right? So wouldn't that mean that we don't have to put it over 1? We already, right? It's unnecessary, right? So if I wanted to find like the sine of that angle, it would just be the length of this side, the opposite side, over 1, right? Which is just whatever the length of this side is. So whatever this is the sine. And this is adjacent, so what would this be of the angle?
This would be the cosine.
The cosine of the angle. Now you could imagine if we open up that angle theta, right, and spin it around the circle, we could have this right triangle located anywhere in the coordinate plane at any particular angle, like 135 degrees, right? And then you know a reference angle, right? So let's say my angle opened up out to here. It's still a radius of 1, isn't it?
Yes.
Okay. And now I have what you learned yesterday, a reference angle that's less than 90. So whatever that big angle is, we could call it 90 degrees. Right? Well, anyway, let's go back to the first page of the notes here. They have a unit circle there with a triangle drawn in. Let's kind of look over it real quick. Back. So, and they gave you a sine again and cosine, right? Opposite over hypotenuse, adjacent over hypotenuse. So the unit circle. The radius of our circle here is 1, right? That's also the hypotenuse of that right triangle in there, isn't it? Okay. And theta is just the angle that's formed when we open up, right, that side of the triangle, hypotenuse. Get that away. I don't want to clutter it up too much. So in part A, given the right triangle, find an expression for the sine of theta. Sine is opposite over hypotenuse, isn't it? Right? So in this triangle, our sine of theta, if we're looking at that triangle, would be what over what? What's in the triangle?
Triangle is 1
Opposite over hypotenuse.
then
What is the
the
side?
opposite of
What is that side labeled as opposite of the angle?
y.
Y over,
Y over 1.
which just equals what?
Y.
Y. Right? So the sine is just whatever that vertical distance is. Okay? Part B. They want us to find an expression now for cosine of the thing, theta. So cosine of that
Cosine, which is
angle,
the adjacent, which is x.
x over
X over 1.
1, but that's just x, isn't it? Right? You kind of get the idea here now, maybe? So do you see this x comma y up here? Right? Order pair of coordinates. Start here and you count over x and go up y, and that's your coordinates. But what did we say x was?
X was the cosine.
So that x comma y, and what's the y equal to?
The y equals sin of sine of.
So any point on that circle, x, y, is just cosine theta, comma, sine theta. Follow me? So this xy up here is cosine, comma, sine. That's the actual coordinates of it in the unit circle. You guys follow me with that? And that's this point right here. Whatever the length of that x is, that's the cosine, right? Cosine goes along the x-axis because that's adjacent, right? And sine goes up and down here because that's opposite over 1, and it doesn't change anything. What about if we drew the triangle over here? Let me draw the triangle, use a different color. Over in this quadrant too here. Okay? So that's still a 1, right? And maybe I'll just call this alpha, right? Because it's different than that theta, okay? Now, here's our y, okay? And what would this distance be here? If it's the same as this distance here, what's this distance? If the one to the right there is x, what would be this one? If this is x over here, we're going to the left, aren't we? So what would
Yeah,
x
be
be?
negative x.
Negative x, right?
So why would y be also negative y?
No. Y is still up top, right?
Oh, okay.
Up, right? So this is not, why do I keep doing red? So this is negative x over here, right? So that kind of changes the sine and cosine, right? Doesn't it? So this negative x now, it changes one or both of them to a negative. Let me draw our angle down here in this quadrant, right? So now this is still negative x, but what is this distance right here?
This distance is negative y.
That's because now we're going down. That's negative y. You follow me? So now we can get the sine and cosine of all these different angles all the way around the circle if we know our reference angle, right? But sometimes the sine and cosine will just be negative. Does that make some sense? Okay. Well, let's just go down here. We go through a few of these. You should start to catch on. All right, so definition of sine cos. So for an angle in standard position, generally passes through x, y, blah, 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 on the unit circle. Good gravy. Need a new smart board. On the unit circle. So the sine of the angle is the y coordinate, right? The up and down part, because that's the opposite in our triangle. And the cosine is the x coordinate, the left and right part, okay? Because that's the adjacent to our angle, next to it. Let's look at this example down here. So remember, cosine is x, sine is y. And we have a unit circle down here. Notice it's 0 degrees, 90, 180, right? What's this one down here? 270. Okay? Let's think about the sine of 0 degrees. So what were you see this angle here? That's not really 0 degrees, right? Everybody agree?
Yeah,
Okay. But if we close the angle down and made it 0 degrees, okay, what is the coordinates of this point right here? What comma what?
it'll be 0,
Is that also 1 over to there?
yeah, be also 1.
So it's 1
1,
comma, and how far up? What's the y direction of this point?
1.
It's up 0,
It's up 0, so it'll be 1, 0.
right? And remember, that's cosine comma sine, isn't it? Of 0 degrees. So what's the sign over here in the box? What's the sign of 0 degrees?
The sine of 0 would be 0
Yeah, technically it's 0 over 1,
over 1, but
right?
it'll be
Because the
0.
hypotenuse is 1, which is just 0. Okay? Now what's the cosine of 0 degrees?
Cosine will be 1.
Yeah, technically adjacent over hypotenuse, but it's just 1, right? It's right. So remember, this is cosine, this is sine. Cosine, comma, sine is how they go. Okay? Okay, let's think about the sine of 90 degrees now. Okay? So now we're going to open this angle up all the way up here to 90 degrees. And so our triangle is going to keep changing, right? It's going to get skinnier and skinnier and skinnier, right? So what are the coordinates of that point up there? If our angle is 90 degrees, what comma what? How far
It would
left and
be
right? 0 comma what? How far up? What number did I just
it
write
would
here?
be 0, comma 1.
1. Cosine, comma, sine. So for 90 degrees, what is the sine of 90 degrees?
It would be sine 90, 1 over 1, but
Just 1,
0 over 1.
right?
Yeah, 1 over 1, which would be just 1.
Okay, what about the cosine of 90?
It would be 0.
That is 0, right? Look at the coordinates you just worked out, okay? Now let's go out to 180. So we keep opening our triangle up, right? So the triangle keeps doing this, right? And we keep bringing that angle all the way around until we get to 180. What's the reference angle here?
The reference angle would be -1.
Well, the reference angle would be 0 degrees, right?
Yeah, it'd be 0.
We open up to 180 degrees, right? But remember the reference is between the x-axis and there's nothing there if we're at 180. So that angle is 0, wouldn't you agree? Let me unclutter this. We just keep opening this up all the way around, okay? All right, what are the coordinates of this point out here? So that's still 1, right? So it's what
Okay,
comma
one,
what?
two,
That's
one,
negative
one.
1. Sorry, that's negative 1. So the coordinates here are what comma what? At
It would
180.
be -1, 0.
And the 0 up and down, right? So what is the sine of 180 degrees?
Sine would be 0.
Yeah, cosine comma sine. So it's 0. What is the cosine of 180?
Not -1.
Negative 1. Okay? Let's open it all the way back to 270. Okay, now this is -1 going down, isn't it? Right? So what are the coordinates if we at this point where we open up to 270? What comma what?
Would be -1, -1.
So
Oh
negative
no, just 0.
0,
-1.
-1. Okay? So then that's cosine comma sine. So what's the sine of 270 degrees?
The sine would be
Cosine comma sine.
-1.
Yeah. And what's the cosine of 270?
0.
0. Let's go all the way back around to 360. Hey, wouldn't that be the same as 0?
Yes.
It's at 1 comma 0. So what's the sine of 360?
Zero, 1.
No, just 0.
Yeah, 0 and then 1.
And
For
the
cosine.
cosine is 1. So you guys have just found the sine and cosine for angles greater than 90 degrees, right? For the first time in your lives. Real simple, version of it, okay? So you kind of getting the idea here? And of course, we're going to be looking at angles like in between 90 and 180 and 270, right? And you learn some pretty common angles. Do you remember special right triangles from geometry class? If any of you had me. I know
Yeah, I think so.
a long time ago. Well, we better do a quick little note then. See note 2. Let's go to our notes page real quick and review this, because this will be kind of key. All right. Let me draw a little line here, and this will be note number 2. See if this looks a little bit familiar. Special right triangles. Does this look familiar?
Yeah, I don't know.
45, 45, 90.
Yeah, all of it.
And so both of these sides are congruent. I'll call those x. Does anybody remember then what the hypotenuse of that is?
The hypotenuse would be x plus x.
No, x times the
X-
square root of
X-
2. It's been a long time, I know. I'm not going to go through again how we did that for you guys in geometry. But remember that height, if whatever the values of those legs are at 45, 45, 90, the hypotenuse of that triangle is always the leg times the square root of 2. Okay? Maybe you recall this one. Our other special right triangle. (30, 60, 90). All right. And maybe you remember in this triangle, everything was based off of the short leg. So we call that x, right? And the hypotenuse was 2 times x, whatever the short leg is. Does anybody remember how long the long leg is? X times what?
Yeah, x square root of 2.
3 in this case,
Oh,
remember? Boy, it's been a while, hasn't it? I thought you guys would have memorized that back when I taught it to you. Never forgot. Maybe not. Well, let's put these guys in our unit circle, right, in the coordinate plane. So let's take 45, 45, 90. Right, let me draw a unit circle in here. Okay, so let me draw an angle of that's a right angle, 45, 45. Okay, so our reference angle there is 40. Our theta is 45 degrees, right? If I put that triangle in like this, right? And this hypotenuse, we know that's 1 because it's a unit circle, right? Okay. Now, if this is 1, right? That side is 1. Or no, if the hypotenuse is 1, sorry. The hypotenuse is 1, right? What is the length of everything else?
The length would be just x.
Right? Wouldn't it be a square root of 2?
Yeah.
Right? Square root of 2 over 2, actually. Right? And that would be the square root of 2 over 2, wouldn't it?
Yeah, because we moved the x.
Right. Because to get from the hypotenuse to the leg, you got to divide by the square root of 2. All right? So the coordinates of this point would be square root of 2 over 2, comma, square root of 2 over 2. And don't worry, if you don't have those, remember, there's a chart that you'll use, right, with these numbers in it, okay? And you can use it on the test as well, okay? Let's try the 30, 60, 90. Let's put that down. Let's put our 30, 60, 90 in the unit circle. I'm going to make it a little bigger. Not so messy. That looks like a unit egg, but we'll pretend. Okay. So let's call this a 30-degree angle, and the other one's 60, right? But that's still 1, right? So what would be the length of our short leg over here? if that's the
Show
hypotenuse.
leg would be 2. 2 divided by
No,
2.
the hypotenuse is
Hypotenuse.
twice the short leg. So if the hypotenuse is 1, what's the length of the short leg?
Just
Half.
1.
Half,
Half. Oh, half.
right? Because 1 has to be twice that. You with me? So that's 1/2. And what's the length here of the long leg?
The long leg would be
X, which is 1 times the
3.
square root of 3. 1 square root of 3, so just the square root of 3. So what are the coordinates of this point? What comma what?
It would be 1 divided 1.
Square root of 3,
The square root of 3
comma 1/2.
over 1/2.
Okay? Right? So we're putting these in the unit circle here. All right? I know, maybe have I lost anybody here? No?
I'm a bit confused how you actually got the 2
Oh, I'm sorry.
divided.
I'm sorry. It's a short leg, so it should be 1/2 the square root of 3. My mistake. Sorry.
Okay, yeah. I was a bit
Which is
confused.
square root of 3 over 2. Yeah, sorry about that. So that should be square root of 3 over 2. Over 2, comma 1/2. All right?
Okay.
They feel better now? Okay. All right, let's go back. And I'm not going to ask you to solve for 30, 60, 90 triangles, right? But I just want you to know some of these. So look at the table they have here. So because of those triangles, we were able to put in the coordinate plane. Remember the sine of 30? Remember, the coordinates of those points are cosine, comma, sine, right? So the cosine of 30 was the square root of 3 over 2, and the sine was 1/2. Right? And for 45 degrees, they're both the same, right? Because it's isosceles. So they're both the square root of 2 over 2. And then 60 is just like the inverse of the 30. That makes sense. Okay? So you might want to have some familiarity with these, right? So this coordinate here for 30-degree angle, where it hits the unit circle, is the square root of 3 over 2, comma, 1/2, like we put in the diagram. What are the coordinates on the unit circle for the 45-degree angle? What comma what?
It would be just square root of 2 divided by 2 and square root of 2 divided by
Right.
2.
Cosine, comma, sine. And what about the coordinates where the 60-degree angle hits the unit
It
circle?
would be 1/2, comma, square root of 3 divided by 2.
Okay? All right. So we'll see if this comes to you. Now let's talk about whether the sine and cosine will be positive or negative, right? So take a look at this diagram. We're going to fill out this chart. So depending on the quadrant we're in, right? This is quadrant 1. And I don't like have you memorize this stuff. It's better if you can just figure it out. It's not hard, right? So remember, this axis, the x-axis, right, is cosine, is it not? Right? Remember, that's our cosine. So on this side, anything over to the right here, wouldn't this be positive cosine? And what about over to the left? What would it be?
It would be negative cosine.
Negative cosine. All right, and so our y-axis was sine. So the top part of our y-axis would be positive sine, wouldn't it? And what would the bottom part be?
Negative sine.
Negative sine for anything down in this lower half. Okay? So basically, everything out here, right, is going to have a positive cosine. You agree with me? And everything over here, any point out there will have a negative cosine, right? But let's look at the top and bottom of it.
So number 1.
So everything up here would be positive sine, right, in those two quadrants, and everything down here would be what? Sine.
Negative sine.
Negative sine in those two quadrants. So let's take a look at the chart here. Let's see if we can fill this out. So what would the sine of our angle be in quadrant 1?
Quadrant 1 would be both positive sine.
Sine would be positive. Yep. And the cosine would be positive as well. Let's go over to quadrant 2, the sine.
Quadrant 2 would have positive sign and negative sign.
Yep,
Negative
it's above.
cosine. I mean.
and negative cosine because it's left. What about down in quadrant 3? Sine
Quadrant
would
3
be
would
what?
have both negatives.
Negative sine, negative cosine. What about quadrant 4?
We'll have a negative sign, sin, but have a positive
And a
cosine.
positive cosine, right? Make a little sense to you? All right, so here's basically the steps for evaluating the sine or cosine of a reference angle. Find the reference angle. You did that yesterday, right? It's the angle that's formed closest to the x-axis, right? You know how to do that from yesterday. And then evaluate the trig function for that reference angle, because that reference angle is always going to be less than 90, isn't it? And then figure out what quadrant it's in and determine whether it's positive or negative. Let's look at some examples. So the sine of 30 degrees. It's probably best to draw, maybe a quick sketch. Right? 30-degree angle. Right? Now, who remembers what this distance was? That's the cosine, and this was the sine of it, right? So what was the sine of 30? What was this distance right here? The
The
sine of 30.
distance would be this whole
Look at the chart up top. Sine of 30.
Would be the sinusoid, so
You mean one
it would
half?
be positive.
One half.
Yeah, 1/2.
God, stupid smart board. One.
So 1/2 of 30 would be 15.
No, it's not half of 30. The sine of
Oh.
30 is 1/2.
Oh, okay.
Okay, that's the opposite over hypotenuse thing there, right? Okay, let's take a look at the sine of 240. Let's make a quick sketch and figure out what angle we're dealing with first of all. So 240 is going to be greater than 180, right? Less than 270. It's going to be like out here somewhere, right? What's the reference angle for 240 degrees? What's the angle? So if this is 180, and
The
that's
reference angle
240, what's the reference angle?
would be 40, no, not 40, 60.
60 degrees, right? Okay, go to your chart at the top of the page. What's the sine of 60
The
degrees?
sine of 60 would be square root of 3 divided by 2.
Okay, is it going to be positive or negative?
Negative.
Negative, because sine is negative down here, isn't it? So it's going to be the negative sine of 60, right? Because it's down there. Which is what then? Negative square root of 3 over 2. Okay, let's try another one. Cosine of 120. Let's find the reference angle. So 120 is bigger than 90, less than 180. So it's probably out here somewhere, right?
And
So,
since it's 180, that would mean to be 60.
so that's 120, and this is 180, right? So this angle is 60. That's our reference angle, right?
And we're doing positive, and we're doing cosine, which is negative.
Cosine is negative over here, right? Because it's going, that's our cosine, and it's negative. So it'll be the negative cosine of 60, right?
That'll be negative 1/2.
Negative 1/2. You kind of following now? Let's try the cosine, the next one, of 315. It's best if you sketch this or you can picture it in your head, right? So we're bigger than 270, right? This is 270, right? This is 360. It's in between those, right? So 315
Which is 45.
be like here, right? So this reference angle you said is what?
45.
Everybody agrees
Degree.
it's 45 degrees?
And we're looking for cosine, which is positive.
Cosine will be positive, right? So what's the cosine of 315 degrees? It's the
Same
same
as 2 divided by 2.
as that. So it is positive square root of 3 over 2. Square root of 2 over 2. Right? Eraser. So much time with that. Square root of 2 over 2. Positive, right? Because it's out there to the right. All right, why don't you guys try these down here? You guys think you kind of get the hang of it maybe now? Find your reference angle. Figure out whether sine or cosine is positive or negative, right? And look at your chart up above. So everybody take a minute, see if they can work. Go ahead and sketch it in here. 35, I'm going to be out here somewhere, right? That's 135 to 180. Isn't it a 45-degree reference angle, you guys?
Yeah.
So what do we get for the sine of 135? It's positive, right? Because it's up top.
Yeah, we get positive. So
Positive what? Look at your chart.
Positive 202 divided by 2.
Square root of 2 over 2,
Well, yeah.
right? All right, let's try 150. We'll move on a little more quickly here. So that's not quite to 180, right? So it'd be like here. Here's our 150. And here's our 180. What's the reference angle?
Reference angle would be 30 degrees.
Okay, they want cosine. Are we going to be positive or negative?
Positive.
Cosine.
No, negative,
Remember, this is our cosine line, right? So it'll be the negative cosine of 30, which is negative what?
Negative. It would be negative. Square root of 3 divided by 2.
Square root of 3 over 2. All right, last one here. 210. Well, here's 270. There's 180. So it'd be like, yeah, here somewhere, right? There's 210. Here's our 180. What's our reference angle?
Reference angle would be 30,
30 degrees.
which is the same thing as
We
before.
want cosine, which is
Cosine,
negative out there.
which would mean that would be negative 1. Square root of 3 divided by 2.
Okay. All right. Well, there you go. That's, you find the reference angle there. We're working in degrees. Okay. We're
Mr.
looking-
Hector,
Yeah.
when you find your reference angle,
Yeah.
how do you know if you're going above it or under it?
It's always an angle between your big angle and the x-axis. You see this thing?
Okay.
See that right there?
Yeah,
That's my 210 degrees, right? I know it's bigger than 180, so it's on that side. And the difference between 180 and 210, right, because we got to go to that, is 30.
okay,
That makes sense. Over here, it was 150, so it's up above the 180, right?
yeah,
And so it's still a 30-degree angle because the difference is 30. So that's your reference angle.
got it.
All right, let's go out of degrees for a minute and switch over to radians. Notice that these are all in radians, the angle, pi over 2. So probably right now, if you haven't memorized these, would be to convert, whoops, y, 2 degrees. Remember, what do we multiply by to do that?
We multiply by the,
180 over pi.
180 by over the pi.
So the sine of pi over 2. It'd be nice to know how many degrees that is because we got a chart in degrees, don't we? So pi over 2 times 180 over pi gives us what?
It would give us 90.
Okay, what's the sine then of 90 degrees? Remember that one? The page before? Sine of 90.
Sine of 90 would be 1.
1. Okay, so we have that other chart that we filled out earlier too. All right, sine of pi over 3 radians. Wasn't that just 180? Because pi is 180, right? And we could do it this way. Switch your degrees. What's 180 divided by 3?
It would be 60.
60
and
degrees.
60 degrees instead of 60
Sine
would
of 60 is
1/2.
square root of 3 over
Oh,
2.
no, yeah, one,
Go to your
yeah.
chart.
go to 3 divided by 2.
All right. Does anybody remember what 3 pi over 2 is in degrees? What's 180 divided by 2? 90 times 3. What's 90 times 3?
360.
Otherwise known as 270. Right? And what was from a couple pages before the cosine of 270 degrees? Remember, that's where the triangle flattens out the nut.
0.
0. All right. All right, one more. 3 pi over 4 radians. I wonder what that is. So 3 pi over 4 times 180 over pi. Pi's cancel. What's 180 divided by 4? Times 3. You can do it in your calculator. Do 180 divided by 4 times 3.
45.
What is it?
45.
Okay, times 3.
Oh, it'd be 135.
135 degrees. So now we need the cosine of 135 degrees. I guess we're going to need a reference angle. Right? 135, that's like out here. 135. This is 180. What's our reference angle?
Reference angle will be 45 degrees.
45 degrees in its cosine out there to the left, which means it's what?
It would be,
Negative cosine of 45, which is?
yeah. The cosine would be negative, yeah, 302 divided by 2.
Okay. All right, one more question here. Terminal ray of an angle alpha is drawn in the same position, and it passes through this point, negative 0.6, comma 0.8. Okay, and it's on the unit circle, which gives the value of sine of alpha. Guys, remember, this is cosine, comma sine. This is really easy. What's the sine of our angle?
Cosine would be 0.8.
Sine of alpha equals 0.8. That's a nasty looking messed up alpha. 0.8. See how simple that part is? Okay? You guys kind of get what's going on here? You just have to know how to find a reference angle from yesterday, right? To get something between 0 and 90. And then you just need to know whether the sine or cosine is positive or negative. Remember, cosine's along the x-axis, and sine is along the y. Anybody have any questions on this? Okay, let me stop that recording there.